y lo que toca es volver a buscar trabajo. Por sectores,
Y el paro marca hoy el mejor agosto de la historia, baja en más de 8.
¿De quién es? Creo que estamos ya. Vale. Okay, Adriana, maybe we can start.
Yes, please. I'm ready.
Okay, we'll start recording now also. Okay, good morning, good afternoon, everybody. This is the first seminar of the year on this Instituto de Astrofísica de Andalucía here in Granada, in Spain. And today we will have the talk by Dr. Adriana Ocampo from NASA headquarters. And she will talk about the Lucy mission exploring the unexplored. Dr. Adriana Ocampo is currently a science program manager at NASA headquarters Science Mission Directorate in the Planetary Science Division, responsible for the New Frontier program. As the New Frontier lead program executive, she is responsible for the Juno mission to Jupiter, the New Horizon mission to Pluto, and 2004 MU69, and the asteroid sample return OSIRIS-REx. She is also the lead Venus scientist responsible for NASA's collaboration in ESA Venus Express mission, JAXA Venus Climate Orbiter, and the Venus Exploration Analysis Group. Dr. Ocampo was a research scientist at the California Institute of Technology in Jet Propulsion Laboratory, where she worked since 1973. Then in 2005, she was the investigation scientist for the Mars Odyssey Gamma Ray Spectrometer, and also worked for the Mars Program Science Division and the Solid Earth and Natural Disaster Program. She worked at ESA from 2002 to 2004 as a senior research staff member responsible for conducting research in comparative planetology of solar system bodies. Dr. Ocampo also completed her Bachelor of Science degree at California State University in Los Angeles in geology with the emphasis in planetary science. She completed her Master of Science in Geology also at California State University with a thesis on Chicxulub impact crater in Mexico. She was born in Barranquilla in Colombia and raised in Argentina. She came to Caltech at JPL as a high school student, where she has the opportunity to gain experience in planetary science. So I think she's a very qualified person to talk about this wonderful mission that will be launched in less than 1 month. And no more introduction. Adriana, the floor is yours. Thank you very much for being here.
Thank you, Rene. Thank you. And I want to thank you especially for giving me this opportunity to share all the excitement about the Lucy mission that indeed, like you mentioned, is we are at 43 days from launch. So it's very exciting times for us. And thank you for the Institute Andaluz de Astrofísica for also this opportunity to join your lecture series. Well, I wanted to start by really sharing the excitement of the extraordinary times that we are living in, because what seemed science fiction for us, perhaps when we were growing up, is science reality today. And before, during our last lifetimes, we will see other humans going to other planetary surface. And with that, I want to share this.
Ignition sequence start. All engines are ready.
Hemos dado pasos enormes.
We choose to go to the moon and call this victory our.
Hemos conseguido lo estremecedor, lo asombroso, lo innovador. Y hemos dejado una marca en los cielos. Cada uno de nuestros éxitos se apoya sobre el anterior y amplifica lo que es posible. Es hora de dar el siguiente gran salto. Estamos escribiendo el próximo capítulo de la exploración estadounidense, volviendo a la Luna para quedarnos y para poder ir más allá, a Marte, para expandir lo posible y aumentar nuestra comprensión. Los planes para estas misiones ya se están definiendo. Iremos con nuevos sistemas, diseños audaces y una misión sostenible. Lo puedes oír, probar, tocar. Vamos allá. Estamos entrenando, probando, infiltrando nuestro espíritu pionero en cada componente, definiendo nuestra determinación. Y de huellas. Se trata de ciencia sostenible y de alimentar el avance del alma humana. Porque somos los pioneros, los navegantes de estrellas, las pensadoras, las visionarias, los emprendedores. Y porque estamos sentados sobre los hombros de gigantes para ir más allá de lo que la humanidad ha llegado nunca. Añadiremos nuestros nombres a la lista de los mayores aventureros de la historia. Cada día, con cada misión, avanzamos esta llamada. Somos la NASA. Y tras 60 años, solo estamos empezando.
Bueno, ese es nuestro presente y nuestro futuro. Y para todos y todas esas estudiantes, perdón, I'm going to go to English again, and my apologies. So this is our present and future. And for all those young students that are online, I invite you to explore a career in space exploration, because space exploration is part of everything we do, and it will be part of everything we do even more in the future. So as you think about ideas for your thesis, be it for your bachelor's, master's, or PhD, study the missions that are forthcoming and what their payloads, the instruments that will be on board, and perhaps you'll capture an idea from that will be the theme of your thesis. Well, with that, I want to start sharing with you this extraordinary mission that we call Lucy. Well, why does the name Lucy? What is the connection between Lucy and what it was given the mission this name, and it really is because in 1974, a humanoid, a proto-human, was discovered by a paleoanthropologist, Donaldjohanson, in Ethiopia. And as Lucy taught us and is teaching us about our species as about our origins as a species, the Lucy mission will teach us about our origins in our planetary system. So there's the link between Lucy the fossil and Lucy the mission. As we mentioned, the mission will be launched on Saturday, October 16th this year from Cape Canaveral and Kennedy Space Center at 5:34 a.m. Eastern Standard Time. So that is going to be a really early morning rise for all of us, but we probably will not sleep the night before and will be ready for lunch that very early. It should be a spectacular a spectacular show that we will invite you, and you're all welcome to participate virtually via just the website of Lucy NASA. You can find the link to join us in the lunch. Let me share now with you just an overview of the mission.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan asteroids. These primitive bodies share Jupiter's orbit in two vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids, embarking on a 12-year odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
Okay, so with that overview, I want to now share with you more details about the excitement of this epic journey that Lucy will be undertaking. And you could see here as the spacecraft arrived to Cape Canaveral, I was transported by a C-17, and you could see it here unloading. And in the far right, I don't know if you can see my cursor here, is where Lucy will reside, and very shortly will be just included inside here the as is put in the rocket in an Atlas 5401, which will be launched on October 16th. Well, let's talk a little bit more about the spacecraft in detail. Lucy is an extraordinary spacecraft. It really contains three main instruments, science instruments, 2 cameras that will help us navigate, the T2 cams, and we also have an experiment using the telecommunication antennas, the high-gain antennas, to determine the mass of the asteroids as the spacecraft flies by them. So we have the LRAF, which is really a camera, and that will be able to, it's really 2 instruments in one, and I'll show you more details and example of the type of information that each of these instruments will be collecting. Then we have L4, all the L's are for Lucy, and then Lori, which is a high fidelity, high resolution infrared, near infrared camera. Then we have a thermal emission spectrometer, L-TESS, and the 2 cameras, the T2 cameras that will enable us to navigate a spacecraft. But we will also use them for science, because we will be using them to observe and potentially discover other asteroids or even rings around the Trojans asteroids, if that becomes the case. Well, I want to, I'll show you more in detail, but these large blue circles are the main source of energy for all the subsystems in the spacecraft. It's the first time we're going really so deep, the NASA sending spacecraft so deep into the solar system, fully powered by solar panels. On board the Lucy spacecraft, there is also a plaque, which it really is like a time capsule. We wanted to send a message to our future generations, for those future space archaeologists that will find perhaps the spacecraft. And in the plaque, we have inspirational messages from, musicians, artists, poets, writers, and including, I think, Ringo from Lucy in the Skies, the song that, in a sense, inspired the name too, because that's why the fossil in Ethiopia was given the name Lucy, and hence also the name of our mission. Well, another important point to note is that the Lucy trajectory can be maintained for about 2 million years. The spacecraft, if we don't do anything, it will just keep going and going for about 2 more million years in that same trajectory. So that's why the team thought that it was important to include a plaque, like a time capsule, sending these inspirational messages. Well, let's talk then a little bit more about, I wanted to give you examples of each of the instruments on board the Lucy spacecraft. As I mentioned, one of the instruments is called LORI, which is a high resolution camera in black and white. Here you can observe an image from Charon, which is the largest moon of Pluto, because the New Horizons spacecraft actually had the same suite of instruments on board, except it didn't carry the thermal emission spectrometers, but it does have the LORI high resolution black and white camera as well, that the RALPH, the instruments that we'll see an example of it, of what New Horizons took in a couple of minutes. But you can see that with LORI, we will be able to determine and study the topography, the morphology of these, the surface of these asteroids, and hence determine its geological history. How did the Trojan asteroids evolve? In this image of Charon, you could see fractures. The circles are impact craters. And, geologists, the way we determine relative ages of planetary surface is by counting the amount of impact craters on its surface. In this case, as you could see, the circles here are all impact craters, and each of those, the more impact craters in a surface, it means the older that surface is. So that's how we determine relative ages between surfaces, and that's what we plan to do as well with the Lucy mission, and as we fly by the Trojan asteroids. Well, here's an image of RALPH. As I mentioned before, RALPH is two instruments in one. It has a multicolor camera, which you can see an example here that was taken by the New Horizons mission of MU69, or more recently named Arrokoth. This was an overfly of Arrokoth that took place on January 1st of 2019 by the New Horizons spacecraft, of really an extraordinary, very interesting object in the Kuiper belt. So with these instruments on board of the Lucy spacecraft, we also hope to detect and be able to detect the composition of the surface with MBIC, and since MBIC is especially sensitive to potential organic molecules on the surface, so it's been calibrated to detect that. So it would be very, very interesting to see what we find in the Trojan asteroids. The other instruments, which is part of the RAV suite, is an IR or an infrared spectrometer. And again, here you could see an example that it was taken on board of LISA, that is on board of the New Horizons spacecraft when it overflew on July 14, 2015, the Charon, with the largest moon of Pluto, in which it actually discovered frozen ammonia on its surface. So the LISA instrument will allow us to determine the composition of the Trojan asteroid surface and this very exotic type of ices that we expect to find on the surface of the Trojans. And finally, I wanted to show you an example of the thermal emission spectrometer here, which is on board the OSIRIS-REx mission. I remember the OSIRIS-REx went and orbit the asteroid Bennu, and it captured a sample of Bennu that it will be returned to the Earth in September 2023. And you could see here, the redder, the higher the temperature, the bluer, the lower the temperature. And these are very minute. It's kind of like a thermometer. We can take the temperature of the surface of whatever is being observed by the thermal emission spectrometer or by TESS. So these minute differences in temperatures or the thermal emission, the asteroids capture the heat from the sun, and given its composition or density, you can determine the mechanical properties by the differences on how that sunlight is being absorbed by the surface of the asteroid. So that would be it's a very good just way to determine the mechanical properties of the surface of an asteroid. Well, what are the scientific objectives of the mission? It will be to determine the geology, map its composition and mechanical properties of the surface of the asteroids that will be overflown by the Lucy mission, search potentially for new satellites. Does any of these objects may have high concentrations of particles that will form ring-likes, and try to determine that very complex geological history and how these family of objects that are called the Trojan asteroids relate to other objects in our solar systems, as we'll see. So Lucy will overfly, will fly by really 8 objects, as you will see. Eurybates, recently the team discovered a new moon that's called Keta. And so we will overfly. The first flybys will be in Lagrange point number 4, which will include then Eurybates, Polymele, Leucus, and Orus. And then we'll go to the Lagrange point number 5, which we will then fly by Patroclus and Menoetius. And I want to point to the different types of asteroids that we will be flying by with the Lucy mission, because this is one of the key scientific aspects of the mission, is the diversity of the Trojan asteroids that will be that will be studied and observed by the Lucy mission. And we have Eurybates with its a C-type, a more carboniferous. Then we'll have Leucus and Orus, which are more D types. They are the most common type of asteroid types in our solar system. Then we have Polymele, which is the tiniest asteroid, a Trojan asteroid that the mission will be overflying. And then we have a very interesting binary equal pair of asteroids that are P types like Polymele. So, and before I wanted to share something because it's something that will be happening very shortly actually in Spain, as we will see, and is in a very unique occultation of Polymele. And I wanted to share, okay, what is an occultation? An occultation is when an object goes in front of a very bright star and then is observed by observatories here on Earth. In this case, we're going to so we use these occultations are extraordinary important techniques for the mission to be able to determine before it flies the Trojan asteroids, their shapes and potential, just the shapes of these asteroids, of these Trojan asteroids. And we have an occultation coming up in Spain on October 1st of 2021. So just 15 days before the launch is going to be a very, very busy time. We're getting ready for the deployment. The telescopes are actually arriving this Friday to Gijón, Spain. We will be conducting there during September 27, 28, that time frame, the rehearsals. We will all be training, and we're welcoming volunteers to help us in this extraordinary deployment campaign of deployment of 22 telescopes that will be deployed along the lines that you could see here, especially the black line. That's where we want to ideally be located, or are 22 mobile telescopes. These are NASA telescopes that have traveled all over the world because we have used the same technique to determine the shape and size of MU69 for the New Horizons mission, which it helped us have a very successful flyby in January of 2019. So we are using the same techniques of occultations for Lucy, and I hope I know the IAA and Rene and Jose Luis will be participating, and we are welcoming more volunteers to help us on this amazing deployment to observe the occultation of Polymele. As I say, Polymele is the smallest object, is the one we know its size and shape the least. So it's very important for the mission. Well, let's talk a little bit about what is our solar system, because when I went to school, they told me, okay, there are 9 planets, that's our solar system. Now we know there's only 8 planets, but we have our solar system is a lot more complex. It's not only planets, it's composed of thousands, if not millions of different objects, asteroids, starting from the ones that you can see highly concentrated in the center, which is the asteroids that resides between Mars and Jupiter. They're called the main belt asteroids. But then we have this whole other family that are composed at the edge of our solar system, of which Pluto is one of them, of the Kuiper belt.
It's 9:30.
Objects. So it's really, our solar system is a lot more complex, a lot more rich than we ever thought before. And the Trojans that reside near Jupiter is another family, and we want to understand how all these families of objects relate, how did they originated, to tell the story of our planetary neighborhood. So where is Lucy going? Lucy's going to the Trojan asteroids. And where are the Trojan asteroids? Well, the Trojan asteroids reside 60 degrees ahead of Jupiter, which is here in the Lagrange point number 4, and 60 degrees behind the orbit of Jupiter, which is Lagrange point number 5. And Lagrange points are really parking spaces in our solar system with objects have accumulated from its formation, and they reside there because it takes very little energy to maintain that orbit. So that's why we have this gray accumulation, and Lucy will go for the first time to study and explore the Trojan asteroids in the Lagrange points of Jupiter. It is important to note that all the planets have Lagrange points, and basically anything very massive in our solar system has Lagrange points. Actually, our planet, the Earth, has 2 Trojan asteroids that have been found in the 2 Lagrange points that are the most stable, because each planet has, or each large mass body has 5 Lagrange points, but the ones that are stable are Lagrange point number 4 and number 5, and that's why the Trojan asteroids also reside there, because those are the stable points, the stable Lagrange points around a planet, in this case Jupiter, for the Lucy mission, which will be overflying. And what we hope to explore, to understand, is some of the key questions on, how did our solar system form? We know we have 4 rocky planets: the Mercury, Venus, the Earth with the Moon, and Mars, and then we have this main belt asteroid that are protoplanets that probably during the bombardment period, more than 4.5 million years ago, they didn't quite form into planets and are the remnants left from planetary formation. But then we get to the large giants, the large gaseous giants planets, which is Jupiter being the largest planet in our solar system, followed by Saturn, Uranus, and Neptune. And how did these bodies form? Did they reside in the same location as they reside today? So these are some of the key questions that we have been asked on how our planetary neighborhood form our solar system. What is the role that the Trojan asteroids played, and did they form the nucleus of these gas giants? And if so, by studying the Trojan asteroids, we can get to understand, it's like looking deep into the gas giants. How the gas giants have changed in position in our solar system. We know they have migrated in position where we see them orbiting today. Most likely is not where they originated. And perhaps how the role that they play in bringing the molecule of water into the internal portion of our solar system that enable eventually for the Earth to capture it and play such a key role for life to start as we know it in our planet. So is that grand story that the Trojan asteroid is going to help us unravel and try to inform a little bit more these key questions of planetary and solar system formation. Well, NASA is going to visit at a record speed, a record number of new worlds, really new asteroids, and at a velocity of more than 145,000 kilometers per hour. Here is our main protagonist, the Lucy Spacecraft. As you could see, has an span of 15 meters, of about 50 feet. And the spacecraft itself, as you can see in the middle, is about the size of a car, and it weighs about a ton. Here I want to show you this extraordinary set of solar panels. As you could see, they are being tested at Lockheed Martin, who's the company that constructed the Lucy spacecraft. And it's incredible. It's incredible technology, because before they are deployed, the thickness of these solar panels is all about 4 inches or about 8 centimeters in thickness. And it's like the solar panels are weaved in this piece of cloth really is quite extraordinary. I love to see the deployment, as you could see, how and we test those in situ. Then we're testing them at Cape Canaveral as well. You know, so we do a final test of all the key subsystems before the final encapsulation before the mission is launched. And Lucy has really a very, very complex, what we call opportunistic trajectory, because with one spacecraft, we can really are going to be visiting 8 new objects. And I want to, and here we have, it's quite complex, this diagram, so I will quickly walk you through its trajectory. And it starts on the launch, as I mentioned, October 16 of this year, then to what we use to really save on fuel and to increment the spacecraft velocity, we use the technique called gravity assist. And you could see the trajectory here in red. And then, so we launch on October 16, and then a year later, almost exactly, October 15 of 2022, we come back to the Earth. We use the gravitational field of the Earth to accelerate the spacecraft, and without using very much fuel. So then that will enable us to go back again, and December 12th of 2024, to again use the gravity field of the Earth to accelerate the spacecraft farther, to then go to our first object that we are going to overfly, which is the asteroid Donaldjohanson, which, as you recall, Donaldjohanson is the paleo anthropologist who discovered the Lucy fossil in 1974 in Ethiopia. And it is this Donaldjohanson will provide us the overflight of this asteroid, will provide us an opportunity to really test all the systems, train the team, do our first true operational, and really have the opportunity of learning about a new object, a new asteroid in the main belt. And this will happen on April 20th of 2025. Then from there, we go to explore the first Trojan asteroid, as you remember, in Lagrange point number 4, because we go ahead of the orbit of Jupiter, and we go and explore Eurybates. And Eurybates, is, as you recall, the team just recently discovered a new moon of Eurybates, which it was given the name of Enriqueta Basilico, or for short, we give it the name Keta, and she was the first woman to carry the Olympic torch. So we wanted to continue in the tradition of honoring great Olympians and athletes. And this will happen on August of 12th of 2027. Then from Eurybates, from August of 2027, we go to September of 2027, almost just a month later, to overfly Polymele, which is the smallest objects, the smallest Trojans that Lucy will explore. Is the object of our occultation in October 1st over Spain. So again, we need to learn more about its shape, its size, to better inform this overflight on October 15, 2027. Hence, why is so important the occultation of October 1st of this year, and why we're doing this large deployment in Spain with the 22 NASA telescopes. Well, then from September 2027, then we go to April, just a few months later, April of 2028, to the overflight, the flyby of Leucus, which is a very irregular asteroid. One of the key questions we want to see is why some of these Trojan asteroids are spectroscopically more red than other, and you could see that we will go after Leucus to explore Orus, which is also another very red Trojan asteroid. And are these is the red due to a lot of maybe the molecular of water that have provided oxidized the surface of these asteroids, of these Trojan asteroids, and that could tell us about the history of what happened, how the water molecule transformed these surfaces in our solar system. And the Orus flyby will be November of 2028. And then from there, we return to the Earth because we finish exploring the Lagrange point number 4, the Trojans, in that region, and we need to gain again more speed, more energy needs to be captured, so we return to the Earth on Christmas of 2030 to do another Gravitia 6 and then go to our final target for the prime mission, which is Patroclus ammunitions. A P-type of asteroid, very, very interesting, a binary set of equal mass asteroids, and we hope to really learn a lot to inform really more about the formation of our solar system and the roles of these binary objects play during the solar system formation. This will take place on March of 2033. That will be the end of the primary mission, but as I said, this trajectory could be maintained for almost 2 million years. So the team will come back to NASA with a proposal for an extended mission, and pending, hopefully, all the subsystems, the spacecraft will continue to perform well, and so there is the potential of continuing. There's a lot more Trojan science to come even after 2033. Well, I wanted to share with you a little bit and just finalizing here because it's so important. All the key of the success of all the NASA missions is due to the people that compose these extraordinary teams of dreamers, that they capture an idea, they propose it, they persist. This is a story of persistence, because you have to remember when the team proposes these ideas to NASA, they've been working probably for 5 years. So by the time they get selected, they've been working on this potentially almost a decade until the mission gets selected, in the case of Lucy in 2017. And now here we are in 2021 launching it. Yeah, and the team is composed of a very diverse group of talents. Here we have the principal investigator, the scientist Donaldjohanson with the beard, so you can see, and the deputy principal investigator, Dr. Kathy Olkand. We have very talented group of engineers that you could see here, group of project managers, and even students. Because this is such a long duration mission. Remember, it will take 12 years in this epic journey that Lucy will undertake in October of this year. So we have a succession plan. We want this very young talent of students to be trained so they can take these positions in the future and continue the legacy of the Lucy exploration. And as part of that, we have what we call a NASA Academy. It's called Las Paz. I invite you to explore this website if you like to, in a future, participate. We are training. We have trained more than 40, almost 5,000 undergraduate students to be part of the mission, and not only of the Lucy mission, but to learn on what it is to be to train the next generation of explorers, of scientists and engineers and technicians. And so please explore this website to be engaged. And there is other ways to participate in the Lucy mission. We are just launching a Lucy app challenge. I'm sharing this website. You could go there, and this is open to all the planet. Everybody can participate, and we have challenges at all different levels. We have 2 Lucy challenges. One is to capture the idea of children on how they perceive the Trojan asteroids and what the Lucy mission, and they can share that via music, via art. Then we have another more sophisticated challenge, and is this using light curves on how the brightness of these objects can really inform the shapes of the Trojan asteroid. So I invite you to form teams. The instructions, you can enroll. This is all free. It's open to everybody. Please explore this website. And the challenge will take place October 1st and October 2nd. So please enroll quickly, because there is a short time frame, and form teams. So it's a very exciting activity to participate. And finally, just summarizing the extraordinary epic voyage that Lucy is going to undertake. In 12 years, it will explore 8 new asteroids with 1 spacecraft. You are all invited for Saturday, October 16, 5:34 a.m. Eastern Standard Time, and you can join us via these websites. And go Lucy, 43 days and counting. Thank you so much for allowing me to share the information about the Lucy mission. We're all very excited, and I'm here if there are any questions. Thank you so much.
Thank you very much, Adriana, for this wonderful talk. And now the talk is open for questions. Please, for doing that, press the reaction button so you can raise your electronic hand, and then I will allow you to make the questions. There are some questions also in the YouTube channel. So please here, any question here? Okay, so the first question, it's coming from the YouTube channel made by Astronautico. He wants to know how long is the internal battery designed for?
Okay, hello Astronautico, thank you for your question. Well, Lucy, as we mentioned, it has its main power source is really the solar panels. So it has the capability really to last for many years, even a century, or more. The trajectory will continue, and as long as the solar panels are able to capture the solar energy, the batteries that it has on board will really will continue to function, and the duration is the lifetime of the batteries are for many decades. So that is we will be testing it. This is also all new technology, because we have never flown this deep into space with with this technology. So we are pushing the envelopes of what the technical capability are, but we hope that they will last for several decades at least.
Okay, thank you. Questions? Another question for Adriana? So I have one. It's really interesting how you or the team will manage the management of the data, because as you say, it is a very long mission. And so maybe the PI or most of the people that are working today, they will not see the data because they will be retired. So they need to prepare the young generations to be ready for the last flyby, of course.
Yes, absolutely. That's a very good question. Thank you for that. Because, you know, one of the requirements that NASA put in place when the mission was selected is you have to have a succession planning.
Yeah.
Really, who is going to have the key, who is going to be training who, and all the key personnel would be able to be, we are all replaceable. You know, it's just a matter of having the knowledge base being communicated, being documented, and that's what is happening. That's why we have even students participating in the mission currently. Many of your students, before Lucy ends, they will have their doctorates. So even if you are in second grade today, by the time Lucy ends, you will have you definitely would have your doctorate beforehand if you go through, and um, and we want them in on board on the team on the mission, and that's why we also put in place the LASPAS, the NASA Academy, to train the next generation of explorers and to train all these people. But also we have to maintain the spacecraft alive, because it's not only succession for humans, but we have this very talented robot that is flying for us that is called Lucy. And the way we are going to, and we will have periods in which the spacecraft will be dormant, you know. So how do we maintain, make sure all the subsystems are working correctly, and we will have the spacecraft will communicate at least once a week with the Earth and say, I'm okay here, and will send us a message, you know, saying that it's okay. Send us a brief summary of all the status of all the subsystems on board the spacecraft. So it's succession for humans, and also maintaining the spacecraft alive for such a long period of time, which we have had experience. I mean, New Horizons, it was a good example. It took us about nine years and a half to get to Pluto. And it continues working, and it continues, and we had to also work a succession plan for the key management positions there, the key personnel, the key knowledge base, and it has been working superbly well. So we know we have a good baseline for Lucy as well.
Thank you. Any other questions for Adriana? Maybe if you want, we can talk a bit about the occultation campaign that will be here in Spain in less than 1 month. If anyone want to ask something, Adriana can answer. Okay, here one hand, Jose Luis, please go ahead.
Hello, Adriana. Thank you very much for this nice overview of the Lucy mission. I wanted to ask you something just out of curiosity. Do you know if there will be observations during the cruise phase? I mean, will the instruments be hibernating, or will they be active?
Well, what we do is we take the opportunity during the cruise phase to, yes, is test, calibrate the instruments in the sense, work in a lot of the software planning, you know, because a lot of the sequencing will be adjusted, refined, and uploaded and tested. We do rehearsals, you know, we do rehearsals in, you know, in which we rehearse here on Earth, like we are doing the Polymele flyby, and go through it. And we do it also with a live spacecraft. So we simulate the sequence of observations with the spacecraft being live, like if the spacecraft was overflying Polymele or one of the Trojans, and then we receive the, you know, the sequence. And so we test and do a lot of rehearsals during that cruise phase. It's really that time, it will be very well used to prepare the team and optimize the science return. So thank you for your question, Jose Luis. I don't know if I addressed everything that you were trying to.
Yeah, yes,
to get.
yes.
Okay, I have another question from the YouTube. This spacecraft have a mobile instruments, or is the spacecraft need to turn to point the instrument as a new horizon did?
Yes. Okay. So it has, you see, the spacecraft has here a platform. I don't know if you can see my cursor.
Yes, yes, we can see it.
Yes. Okay. So that's really the pointing platform where all the instruments pretty much reside. And here is a bigger image of that same location. So the platform, all the instruments are fixed to that platform. So the platform needs to move, and pending what the observation, we may also need to move the spacecraft. So it can become quite complex, the sequence of observations. But one of the tests and calibrations that we will be doing as well during cruise, like where Jose Luis was asking, is we'll be doing a calibration of the alignment of the focal plane of all the instruments, especially, Lori and Ralph. So and Lisa, so is one of the so we will be basically turning on all for some of the sequences of the observations, all the instruments at once, but except, the thermal emission spectrometer needs to be turned at different times than the other instruments. The other instruments need the sunlight. The thermal emission spectrometer, in the contrary, can observe really in the dark to just differentiate and doing in the terminal areas of the object to be able to determine maybe even more sensitive to temperature differences. So it all depends on the angle of our flyby, on how we will be approaching. And the team has been working very diligently in already developing all the sequences. All the sequences have been put on board of the spacecraft, so they are autonomous. In case, in the worst of cases, if we lose contact with the spacecraft has a little bit of artificial intelligence, if we could call it that, to execute these sequences autonomously, and then record the information. And eventually, when we capture the signal, supposedly in that, in that scenario that I'm just describing, which is not a nominal scenario, I'm describing as an anomalous scenario in which we lose contact with the spacecraft could still capture the information and eventually return it to the Earth. So, but going back to the pointing platform, yeah, it's a fixed platform. It has it's like an arm, and it has like a hinge that it could move and rotate at different angles. And but some observations will also require the reorientation of the spacecraft.
Right.
So it's a very complex dance in a sense as the spacecraft will fly by each of these objects. Thank you for your question.
Okay, thank you. One more opportunity. I know Adriana need to go now, so one more question. None in the chat. So thank you very much, Adriana, for this wonderful talk. Hope we can see each one together in 1 month here in Spain in the Occultation campaign, or for another online talk. Thank you very much.
Thank you so much for the opportunity.
It's 10 o'clock.
Bye-bye, everyone. Go,
Okay,
Lucy.
bye.
Bye.
Okay, I stop recording. Now I stop the record. If you want to change to Spanish.
Sí, claro. Desde ya. Sí, okay. Stop sharing, here we go. Sí, bueno, no sé si tenían lo que le estaba comentando, no sé si José Luis estás ahí.
Sí,
Sí, a René anteriormente, que bueno, que uno de los retos de la ocultación que para el equipo de voluntarios es que vamos a necesitar realmente 4 días de esas personas y es una imposición bastante grande. Estamos viendo la forma si podemos obtener financiamiento para financiar alguno ¿no es cierto?, la estancia o algo. Y es uno de los retos que estamos tratando de solucionar ahora y también para tener suficientes voluntarios, porque realmente son 22 telescopios, cada telescopio idealmente